This is video instruction for notes on moles, assignment 49. Before you begin, please have your periodic table handy so you can follow along. What is a mole? A mole is a conveniently sized package. So this is the idea of a mole as a box. We used boxes in Atom Mart. Each box is a mole. The package will be atoms or molecules. Depends on the substance. And I've got my visual here. For example, 1 mole of sodium hydroxide is a package containing 40 grams of that substance, because the mole is a package related to the molar mass. This should make perfect sense to you. 1 molar mass is the weight or mass of a mole. There are 2 main skills when working with moles. One is be able to say grams and moles are related. First question, what is the weight of 1 mole of? Let's make this simple. KBr. So there you'd get out your periodic table and say potassium bromide. You've done this before. 39 for the K, 80 for the Br. Will get you 119 grams. And now I'm using the special word of the day. It's grams per mole. So what is the weight of 1 mole? 119 grams. Now, question B. A little more specific, a little trickier. But you can see it will be proportional reasoning with grams and moles. So random number. How about 2.43 moles of NaBr, sodium bromide? Proportion with labeled numbers. I could do it this way. 2.43 moles is, I don't know how many grams, so that'll be my X. This is the question in words, this is the question mathematically expressed. The correct ratio will be the molar mass. So find the molar mass of sodium bromide, NaBr. Pause the tape so you can find out what numbers to put in these blanks before I show you. Here's my calculated molar mass, 103 grams per mole, so 103 grams is 1 mole. This is now set up for me to solve for X. Please calculate your own value before I show you the answer. Here I'm doing 2.43 times 103, which gives me my answer. 250.3 grams of NaBr is my official answer. Now I'm on question C. I'll make up a number here. How about 4.27 grams of, let's make this be MgSO4. So 4.27 grams of magnesium sulfate. How many moles are there? Suggests you should have a proportion with well-labeled numbers. You try to set it up before I show you the answer. I'll need a molar mass. 24, 32, 64 equals 120 grams per mole for magnesium sulfate. So my proportion, we'll use that as a ratio. 120 grams is 1 mole of MgSO4. Notice my clearly labeled numbers. I don't have 120 grams. I have 4.27 grams. That would line up with the 120 grams on the other side. The X would represent the moles. How many moles of magnesium sulfate is this going to be? Every number is labeled. Now it's time for my little calculator to do the work. Here's my algebra. I'm cross multiplying. 120x equals 4.27. I'm not putting labels on the algebra part. It gets too complicated. But here I'm doing x equals, and now I'll use my calculator. 4.27 divided by 120. And I get this small number here, 0.0356. 0.0356, and that is moles of magnesium sulfate. Notice the scale was interconverting grams and moles. You can go in either direction, from grams to moles or from moles to grams. The conversion factor that allows you to do that is the molar mass. That's the ratio that relates these two quantities. Skill number 2 is using mole ratios from a balanced chemical equation. The coefficients are the mole ratios. Here's my first example. In the equation above, if you start with 6 moles of silver nitrate, how many moles of sodium carbonate would be required? This is supposed to be a 5-second question. Pause the tape and see if you can come up with an answer in just a few seconds. The key to the question is the mole ratio, 2 to 1. 2 moles AgNO3 to 1 mole Na2CO3. So that would mean the correct answer to the question, without any real math, is 3 moles Na2CO3 are required. 2 to 1 mole ratio. 2 to 1 is 6 to 3. In B, it won't be immediately obvious to you. We'll have to use some mathematics, and it suggests proportional reasoning with labeled numbers is the way to go. Let's put in a number here, 1.11 moles of NaOH. How many moles of ferric hydroxide can be formed? So I'll underline for you that it is a mole ratio using the coefficients. Some people need to write in the 1 here. If so, please do so. Set up your proportion with labeled numbers. Check it against mine. You'll notice I made really long lines here so I can write words. The ratio is between the moles of NaOH and the moles of FeOH3. The top line will be, for me, the experimental version, and the bottom will be the known ratio. So the experimental version is 1.11 moles of NaOH, and I don't know how many moles of FeOH3. The balanced equation tells me that the true ratio is 3 moles of NaOH for every 1 mole of FeOH3. So there's my setup, and now I need to solve for x with some algebra. So you solve before you check the answer with me. My algebra looks like this. 3x equals 1.11. Therefore x equals 0.37. That I get on the calculator. And that I label moles of FeOH3. You'll notice I am using the abbreviation MOL for mole. That's as short as you can make it. You cannot make it MO. It's not mo, and it's not M, because M stands for meters, not moles. Last question on the page. It's a mole to mole conversion. It does say you must start by writing a balanced chemical equation. That will provide you with the needed ratio. In this case, I am going to provide you with the answer, and I'm going to hope that you can show the proper work for how to get this answer when you come to class tomorrow. Here's the answer that you should get if you've done it correctly. So when you come to class, I'll be looking for what's your setup, what is your balanced chemical equation, what is your proportional reasoning that leads to this answer.